Assalamu alaikum students. So our today's topic is polar and parametric equations. So the graph of a polar equation r equals f theta is the same as the graph of the parametric equations x equals f theta cos theta and y equals f theta sine theta. If you remember from the rectangular equations and the polar equations, these are the parametric equations. Parametric equations have two equations in which both the equations they depend on the same parameter. Here we can see they both depend on theta. So if you remember the the rectangular equation x equals r cos theta and y equals r sine theta, we are just replacing r here with f theta. That's why we get f theta cos theta and r with f theta, so we get y equals f theta sine theta, where theta is the parameter. So for each polar equation as a pair of parametric equations, because parametric equations are two equations, we can write these polar equations can be changed to parametric equations. Parametric has two, so it should have two equations with x and with y. The first one would be x equals f theta cos theta, where f theta is r. So here my r is 3, so my two equations would be 3 cos theta, and the second one would be y equals 3 sine theta. Okay, the same thing, writing these polar equations to the parametric equations, so we will have two equations in terms of x and y. So the x one would be f theta cos theta. This is f theta because r is equals to f theta. Here you can see that. It would be 4 sine theta cos theta, and y would be equal to 4 sine theta sine theta. So now we can end up with saying that y is equal to 4 sine squared theta. Okay, so the equation was just to change the polar to parametric equations, keeping in mind the polar equation has two parametric equations. I can show you on my calculator also. It will end up with the same graph. So first of all, let's go change this to polar equation, and now let's graph r equals 5. Now let's graph this. R equal 5 is this, with a radius of 1, 2, 3, 4, 5. Now I'm gonna change r equals 5 in terms of parametric equation, as if r equals 5, then my parametric equations would be x equals 5 cos theta and y equals 5 sine theta. So before we change it to parametric, I want to change the mode to parametric equations. Let's go down to parametric equation, change it to parametric equations. Now you will see in parametric equations you have two, x1 y1, and this t meaning it's theta, 5 cos theta. How do I do that? I just did x as 5 cos and this t as representing theta, closed, and then y would be 5 sine t. When I graph it, you can see it is same as we graphed r equals 5. Okay, so now let's go back to our packet. Write each pair of parametric. Now they are giving you the parametric equations in terms of sine and cosine. Okay, we have to change these into the rectangular form by eliminating theta. So if you remember the last topic, parametric equations, getting rid of t, we were writing in terms of rectangular equations, right? here we have to keep in mind, because we have sine and cosine, first of all we will isolate cosine theta here and sine theta here, like we did for t. Okay, so if I isolate cosine theta, I get cos theta equals x over 3, and here I get sine theta equals y over 2. Once I get these two, now I'm going to use trigonometric identities to eliminate the parameter. Okay, so I'm going to use this reference sheet. I'm going to look for the identity which has sine and cosine both together. If I look into this reference sheet, the only identity I found is sine squared theta and cos squared theta together, because I want them combined to give me one equation. Okay, so I know my identity is cos squared theta plus sine squared theta equals to 1. I have this identity. Using this identity, I'm going to replace cos theta and sine theta here. When I replace cos theta, I get x over 3 whole squared plus y over 2 whole squared equals to 1. I end up with x squared over 9 plus y squared over 4 equals to 1. So this is my final rectangular form of the polar parametric equations, or parametric equations in which theta was the parameter. Okay, so don't forget, you have to use trigonometric identities to eliminate. First of all, isolate that trigonometric function and then use the identity. This looks similar to what we did right now. I'm going to do this question. Now here I have x equals sine square theta, y equals 4 cos theta. I'm going to isolate. This is already there, sine squared, x equals sine squared, but I have to isolate cos here, so I'm going to do y over 4 equals cos theta. So now I have to look for an identity in which I should have sine squared and cos squared, so I can combine them together. When I look through this, I get sine squared and cos squared. This is the only one which I can find. So sine squared, instead of sine squared theta, I will be using this, and instead of cos, I will be squaring this part. So I'm using the identity sine squared theta plus cos squared theta equals to 1. I already have sine squared theta equals to x. I'm just going to replace x plus cos squared theta. I'm going to square that, which will give me y over 4 squared equals 1. I end up with x plus y squared over, sorry, it's x, not x squared, over 16 equals to 1. And now getting rid of this, making the denominator same, I get 16x plus y squared equals to 16. I just multiplied throughout the equation by 16. This is my new rectangular equation. Let's do the last question. This one. This is already isolated cos 2 theta, cos theta. I have to just look for the identity where I can have cos 2 theta and cos theta same, both at the same time. So I can see this equation, this identity. It says cos 2 theta equals 2 cos square theta. I can square my cos, right? So I'm going to use this identity, which says double angle identity, which says cos 2 theta equals to 2 cos squared theta minus 1. I'm going to plug in these rectangular, these equations. Cos 2 theta is x is equal to 2 cos squared theta. Cos squared theta would be y squared minus 1. So this is my final equation. What we just have to do is isolate for the trigonometric function, and then look for the identity, and then implement those identity. I hope you understand this topic. Thank you. Assalamu alaikum.